Okay, we have some special exceptions when solving these systems of equations. Let's take a look at this one. So if I want to maybe solve this one by elimination, I might multiply this by -1. So it makes it negative x plus negative y equals -10. And then I add them together, right? Negative x, negative y, -10. Then I get 0, 0, 0 x's, 0 y's equals 0, right? So I get 0 equals 0. So this is kind of odd. Like my variables have completely dropped out, both x and y. So what do I do in this case? Well, is 0 equals 0 true? Yes, it's true. So that means that there are a number of solutions, right? I could put in something that makes this first equation true, like 5 plus 5 equals 10. All right. So that would be true. And also, that would be true for the second equation because it's the same equation, right? Or I could try, 6 plus 4 equals 10, which also makes that one true, or 3 plus 7 equals 10. So there's actually an infinite number of solutions. That's what we say here. And they all happen to be on that line. So if I were to graph this, it would actually be the same line, right? This line, x plus y equals 10, looks something like that, and then x plus y equals 10 graphs right on top of it. So as long as it's a solution to the line, it's a solution to both equations. Okay, so you can recognize that by when you come down here and both variables have dropped out, you have something like this, 0 equals 0. If it's true, there's infinite solutions. If it's false, that means it can never be true, and there's no solutions. Okay, let's do this one. So this one I would probably do by substitution, and as you're looking at these, I would try to develop a strategy. What do you think is the best way to solve this? Do I substitute, or do I try to line things up and eliminate? I could do either way, right? They both work, but I have to move the x over to the other side, so I think the best strategy here would be to do substitution method. So it's already solved for one variable, so I just substitute in for y, that whole expression. So I get 3x minus 3 times the quantity x plus 1 equals -3. So then I distribute that, so it'd be -3x, -3. So I have 3x minus 3x, which is 0, right? And so it dropped out, and I get -3 equals -3. So this is true, right? So this is another case where it's infinite solutions. All right, so that's how they look when you cancel out both variables. It ends up telling you that actually there are multiple solutions. Anything that makes this original equation true will also make this second equation true. And you could rearrange things and actually they would be the same equation. This one just divided all by 3. Then you have x minus y equals -1. And if you manipulate things around and move it around, you can make it look just like that one right there. Okay, let's do a couple more. So this one, I'm going to try elimination method. I'll multiply this one by -2. So it makes -6x, -12y equals -20. Add the two equations together, so I get 0, 0, and so this whole side is just 0, and then this is -15. So this is actually a false statement. So this has no solution. Okay, so no values of x and y will actually make 0 equal -15. Okay, I'll do this one by substitution. So y is equal to 2x, so I'm going to substitute in. So -2x plus 2x equals 10. So -2x plus 2x is actually 0. 0 equals 10. So this is no solution again because it's false. Okay, when you graph these things, you will see that equations that have no solutions actually have no intersections. So they look like this. They are parallel lines that never cross. And you can actually manipulate these equations to show that if I put it in y equals mx plus b form, they would have the same slope. So they would have the same m value. So if I had, maybe I'll call this equation y1 and this equation y2, it would have the same m value but it would have a different, so let's say plus c maybe, it had a different y-intercept. So this one has an intercept at b, and this one has an intercept at c, for example. But they both have the same slope, going up m over 1, m over 1. Okay. The possibility that it has an infinite number of solutions, that is when it's the same line. So it would look something like that, would be the first line. And the second line would be right on top of it. So actually all the points that make up that line would be true for both lines. So all of these points make the system true. And that's how it works.